Good morning, everyone, and welcome to the last day of this year's Data for Good Exchange event. I hope you've all been enjoying the week so far, and we're delighted to have such a broad and diverse audience from across the nonprofit sector. For today's session, we'll be covering a spotlight on predictive analytics, and joining me today are two experts from JPMorgan and Bloomberg. Firstly, we'd like to introduce Rio Achuzia, who is a data scientist in the funds and data science team at Bloomberg, as well as Andrea Solder, who is a CIB Applied AI Machine Learning Lead at JPMorgan. So with that, please do ask some questions throughout the session, and we'll have some time at the end to cover those. So I'd like to hand over to Rio to kick us off.
Thank you. Can we have the slides, please? Great, thanks. So good morning, everyone. My name's Rio, and today Andrea and I will be discussing predictive analytics with you. So first, just a high-level overview. So predictive analytics is actually one of a number of different kinds of analytics that fall under the umbrella term business analytics. And really the goal of business analytics is to leverage data to improve operations and decision-making in an organization. So the diagram on this slide illustrates the first three stages of business analytics. They are descriptive, diagnostic, and predictive analytics. And so in this session, we're going to focus on predictive analytics, but I think it's helpful to frame predictive analytics in relation to the other parts of business analytics because really they build upon each other. So descriptive analytics first. This was the topic of a session yesterday, which perhaps some of you attended. And really descriptive analytics can be considered to be the most basic form of analytics. So descriptive analyses attempt to answer real questions about your organization, revealing patterns or trends that you may notice, you may not notice without really digging into the data. And descriptive analytics just tell you what's going on, essentially. So the kinds of questions that can be answered through descriptive analytics are things like which services are clients using most often, or when are they using services, where are your clients, where are your donors geographically, things like that, helping you build up profiles, and so on. And once you have a solid understanding of what's going on in your business or in your organization, you're then in a better position to ask more complex questions. So the second stage of business analytics on this diagram is diagnostic analytics in orange. And really this helps you to explain why certain things are happening in your organization. So for example, a descriptive analysis has shown that there's a link between social media engagement and volunteer signups, but you want to dig deeper. So you want to understand the nature of this link between social media and volunteers. So you want to analyze your social media data, your volunteer data using certain software packages such as Python or R, and you can then perform correlation analyses on the data across different data points just to get a deeper understanding of the interactions there. And this could lead you to conclusions that you may expect, or even conclusions that you didn't anticipate. So for example, you might find that volunteer signups have more to do with the day of the week or the time of day than anything else. But regardless of what the conclusions of your analysis are, you're always in a better position once you know. Also, as a side point, one of the most powerful tools for descriptive and diagnostic analytics are data-driven visuals, particularly in the form of interactive dashboards. And this is a topic of yesterday's session on visual storytelling, which you can catch up on, I believe, later on. So the third stage of business analytics, and the focus of this session, is predictive analytics. And predictive analytics really follows directly from descriptive and diagnostic. So once you know what's happening in your organization and you have a good understanding of why, you're in a better place to then make predictions about what's going to happen. So predictive analyses make use of statistical methods and machine learning, AI, and things like that, to predict outcomes based on historical data. So again, using the social media engagement and volunteer signups as an example, you may want to know how many volunteers you're likely to have in 6 months' time. And how you would do this is by performing a predictive analysis, so building a predictive model using historic data on volunteer signups, volunteer retention, or any other data that correlates with these. So for example, maybe social media data would also be added to the mix. And then you can use this to estimate future signups and retention, and ultimately to predict your volunteers at a future date. So as well as making predictions about the future, like in that example, predictive analytics can also help us evaluate potential outcomes. So what do I mean by that? So say we can build a predictive model to help us choose which actions are likely to produce the best outcomes by comparing different inputs. So a concrete example, an organization might wish to increase the number of visitors to a particular page on its website. And there are a number of ways that they could go about this. Obviously, they could run ads on social media, they could run ads on traditional media, they could promote their website in search engines or anything else, number of strategies. But to understand which strategy and which combination of strategies would have the best success, if they have historic data for doing these kind of things, then they could build a predictive model which could estimate the number of visitors, for example, given different strategies. So really, so that's just an overview of business analytics. Can we move on to the next slide, please? So following on from that, so this slide illustrates the predictive analytics cycle. To go over this, I'd like you to imagine a charity, so perhaps like a food bank or an organization like the Felix Project from the keynote on Monday, that will have to deal with a problem of perishable goods. So starting in the top box, you have a key question. You want to know how much produce will spoil. Now, this is a problem that we can potentially use predictive analytics to solve. So once we know the question we'd like to answer, we can begin collecting data to help us to answer the question. So in this example, we're assuming we have historic data for things like inventory, donations, purchases, deliveries, and obviously food that goes bad and needs to be thrown away over a period of time, let's say a year. So once we have our data, we can then start our analysis. So that means building visualizations, performing correlation analyses across the data. This can help us really understand which data points are relevant, which are adding noise, and which ones we need to throw away, and so on. And once we're in a good place with the data, we can start to build predictive models. So predictive models tend to make use of algorithms which are familiar to data scientists and data analysts. And really, these people are well placed to do this kind of analysis. So data scientists would generally explore a number of different approaches to developing a predictive model, and they would do so in an iterative fashion. So by improving the model over and over again, incrementally. There are tools and services which can simplify and automate aspects of this model development. Most of them are premium services, but the end product would be a model which you could use to make predictions about whatever it is you want to predict. In this case, obviously, how much food will spoil and how much food will be wasted in a future date. And then the reason why this is a cycle as opposed to like a line is because once you're at the end point, obviously, you know how much food you're likely to throw away. You will now have another question. So you might want to know, okay, I know how much I'm going to throw away. How do I minimize this? Or perhaps something specific, if I change my delivery patterns or my delivery schedules in a specific way, how could this impact the amount of food I'm wasting? So in this way, you can iteratively improve your model, and then you can also potentially build future predictive models to generate new insights using the data. Next slide, please. So here we have a slightly realistic example of how predictive analytics could be used using a company we've made up called Recruit You Inc., which doesn't exist. You can Google it, it doesn't exist. And this company, imagine it, it works with charities. So it works with charities and other nonprofits to recruit volunteers and to manage recruitment campaigns on behalf of organizations that don't really have the resources to manage campaigns by themselves without any help. So Recruit You Inc. offers a number of different strategies to recruit volunteers. They do things like clipboarding, targeted areas, setting up booths at events, online campaigns of various kinds, and so on. It has historic data collected over the last 2 years since it began operating. And this includes operational data, data about its staff, client data, volunteer data, and so on. And then this organization has already found some success leveraging its internal data to actually understand its business and also to improve its operations. So it's already leveraged its data to make some operational decisions already. So it's in a reasonably good place. And you can see on the right-hand side of this slide, the results of some preliminary analytics that it's done. Again, this is all made up. But the organization has had some success with descriptive and diagnostic analysis. It has a good grasp of how much different recruitment strategies cost to implement in different situations. It's also used its historic data to generate stats for volunteers based on how they were recruited. And it's also been able to generate basic volunteer profiles. And really, they want to expand on this going forward. Yeah, next slide, please. So given that it has a couple of years of reasonably good data, we can say that Recruit You Inc. is quite well placed to start answering the more challenging questions that predictive analytics will allow it to answer, so operational questions. So the first example on the slide, we can see that they want to start using their data to automatically choose the most effective recruitment strategies or combination of strategies depending on a specific client request. And one of the ways of approaching this would be to take their historical recruitment data. So we're assuming they've been operating for 2 years, they have all of this data on their system, and then you can apply data science techniques to compare the values within each recruitment campaign and rank them by some success metric. So for example, you might decide that what you want to optimize for is cost. So you want to have like the cheapest campaign for the best results, or maybe you want to optimize for client feedback. So you want to have you want to repeat campaign strategies that have the best feedback from clients, and that's what you care about. Or maybe you want to have a combination of these different metrics and then combine them, and ultimately you would come up with a number, because a number is what like a machine would understand. And then that number, we could call it the score for the recruitment campaign, would be calculated so that the higher the score, the more successful the campaign was. And this scoring model, so this effectively giving the score to the inputs would be the model. And that could be our predictive model. So that this model is then able to predict a new score for new inputs. So the new inputs would be a new client request, and it would be given a score by the system based on historic data. And that would allow you to modify the strategies that have been applied to maximize the score. And that would, ideally, given good data, that would mean that you could essentially repeat your past successes and avoid past failures by attempting to, maximize some number. Another example, Recruit Inc. wants to allocate its own staff most effectively in order to manage its recruitment campaigns. And there are a number of ways of building a predictive model for this particular example. So one of them is essentially to repeat what we did before, so which is taking historic data and coming up with some kind of scoring mechanism for the inputs. This would definitely work, but it might be difficult to scale. And I'm just thinking if you might run into issues if you're trying to staff multiple campaigns simultaneously. So there are other approaches then to build your predictive model. And in this case, it could be remodeled as a matrix optimization problem, which essentially just means you could turn the problem into a matrix or a spreadsheet, right? So a matrix is just analogous to a spreadsheet. It has rows and columns where each row is a member of staff and each column is some data point about that member of staff. So just imagine that a data point, a spreadsheet with all the staff as columns, as rows, and all of the columns as things about the staff, for example, how many campaigns they've managed or average client feedback scores, or whatever the data points you think would be relevant in order to choose the correct member of staff. And then you could create another matrix or another spreadsheet which contains data about the client requests. And then it's just a case of, and there exist algorithms to do this for you, selecting the best combination of rows across the staff matrix, across the staff spreadsheet and across the client request spreadsheet, which are most optimal based on how you're attempting to organize the staff. So you could organize them by their experience with the type of campaign, or the score that they've arrived at using, some score that you've arrived at using historical data and statistical methods, or you could just spread the talent out as evenly as possible based on the different scores so that no campaign is left without good staffing. So really, those are just some examples of what you could answer, questions you could answer with predictive analytics. And now I'm going to hand over to Andrea, who's going to discuss interpreting these analyses and go over some more concrete examples with you.
Great, thanks, Rio. So yeah, as Rio has mentioned, I think we can move to the next slide while I talk a little bit about what we're going to go through during the second section of this panel. The idea here is for us to share some of the concrete use cases that we've identified within JPMorgan and that we've been able to solve through the use of predictive analytics. I think the idea is to give you share some of the lessons learned and the takeaways that we've had from our experience with predictive analytics. I'll be sharing a couple of case studies. I will also talk a little bit about what are the best places to start as an organization to develop these capabilities internally. We will be sharing some useful resources at the end as well. But before I get into the case studies, I want to emphasize what are, I believe, the key takeaways that you should be taking from these. The first important point is that predictive analytics can be leveraged in a lot of scenarios, even in instances where you don't actually need to necessarily predict something. And this is going to be a common theme through the case studies. But the prediction can be used in a lot of different ways, including things like anomaly detection. So if you're able to predict what should happen, then you can compare that prediction with what actually happened. And based on this comparison, you can sort of go back and look at all the variables that you've been feeding into your model and trying to figure out what went wrong at some point in a process. These models are also capable of learning relatively complex patterns, complex correlations between variables. And so applying predictive analytics is a journey, and it's a bit of a journey within the journey. I know the whole event has been taking you through the data journey, and predictive analytics in a way it's its own journey. I will be sharing again some of the learned lessons that we've had. But I also want you to keep in mind that the case studies that we will be sharing with you are the result of these journeys, right? This is not where we started from. And as I go through, I would like you to start and try and draw some parallelisms between what I'm talking about and what are the problems that your organization is facing. And then maybe we can talk a little bit more about it through the Q&A at the end. So if we go to the next slide, I'm going to be sharing the first case study. And this is an internal case study from the JPMorgan Applied AI team. And this was, our goal was to try and improve some of JPMorgan internal processes by looking at how our workforce is operating and how our employees are using the tools that they have available, how they're spending their time, with the goal of making their life easier, making sure that they're as productive and as effective as they can be. And this is the first example where we don't actually need to predict what's going to happen and what our workforce is going to do. As a prediction, it's actually a fairly simple prediction because there's not a lot of variety in some of the day-to-day tasks that some people perform. So the prediction itself doesn't necessarily have a lot of value. What we get value out of is, again, comparing our prediction versus the reality that we then observe to identify anomalies. And then we can zoom in on these anomalies, and it's almost a reverse engineering process on the predictive model. We can extract correlations, and we can sort of trace back from the anomaly all the way to the root cause of their anomaly. And this is an extremely valuable data point for us. Something to keep in mind on predictive analytics, you've already had sessions throughout the event on descriptive analytics, on data visualization, on data storytelling. The predictions or the data that you get out of a predictive model actually feeds back into the same journey. The model itself is not capable of answering complex questions. It's the layer of data exploration on top of what the model is producing that's actually generating potentially a lot of value for an organization. So through this case study, we've been able to identify some pain points for our workforce that tend to be immediately actionable. And again, they are actionable because we are able to trace back the issue to the root cause. The change that we make can then be measured. And this is a data-driven change, which really can help, especially an organization as large as JPMorgan, it can really help us to drive efforts in the right direction. But this process also gave us a much better understanding of the activities performed by our workforce, which has allowed us, for example, to identify some valuable tools that we know were increasing productivity. So, for example, we can focus our training efforts for certain teams and certain tooling. And as you look at these, again, it's about drawing parallelism from what I'm showing you and what you could potentially apply to your organization. Think about your own internal processes. Is there potential for you to optimize how you're doing things? Think about these as identifying effective communication channels using the anomaly detection piece. Understand, just like we've been able to understand our workforce, can you understand donations? Can you identify commonalities between your donors? Can you understand how they react to certain emails and certain events? If we go to the next slide, then there's a second case study that we want to share. And this is one of our outward-facing projects. So the goal here was to work together with our investment bank and try and engage and improve the way we engage with our clients. So how do we go on about enhancing client engagement? What do our clients care about? In this case, we've been sort of ingesting extremely large quantities of data. And this is actually, some of it is publicly available data. It's not internal JPMorgan data. So we look at market data, but we look at our client interactions. We look at a number of data sources, and we try and identify some events that we believe our client would be interested in. So in this case, there's again an element of using predictive analytics not to make a prediction. But once you train these predictive models and you understand how each variable is influencing future scenarios, then you can play this sort of a what if game with your variables. And so you can ask questions like, okay, we know, this observation gave us this value, but what would happen if this value was to skyrocket all of a sudden? How would markets react to this? How would this impact our client? And so we can, all of a sudden, we can quantify risk based on some of these what-if scenarios. Again, there's the element of creating an expectation, creating a prediction, and comparing it to real-life observations. And in this case, it's not just for anomalies, but this can also show us if we've been missing some opportunities that we could have captured. And so there's a big learning opportunity there for the client engagement team. And again, from your point of view, this is obviously outward facing. So just like we have our clients, you also work with people outside your organization. Think about how you're interacting with them. Think about how you're targeting, for example, for a fundraising. Can you identify better candidates? Can you create events that are a little bit more tailored to your audience? Can you streamline the preparation for some of these events, optimizing, for example, for what you think will be the most effective way of communicating with them? So these, again, just two of the case studies that I wanted to share with you. But if we go on to the next slides, there's a number of things that we have onto the next slide. Thank you. There's a number of sort of lesson learned and takeaways that we have had to learn ourselves. So I'm sharing them with you in the hope that you can avoid some of these mistakes. And I think a lot of the points that I'll be making now are also useful when having conversations with the wider organizations, with what will be your stakeholders, or when you're deciding on what efforts you want to fund. All of these elements can help driving the conversation about how can predictive analytics create value? What is the journey going to look like? What should our expectations be? And so I'm going to start from the top left, talking just a little bit about identifying a realistic use case. I won't talk much about this because I know there was another session entirely dedicated to understanding how to identify a use case and how to quantify value. But obviously, the data availability element is a very important piece. Even in Rio's example, the sort of prerequisite was for that company to have already collected a couple of years of good quality data. So there is always going to be a constraint, even more so with predictive modeling. But some things that are a little bit more unique to predictive analytics is understanding the problem complexity. It's very important, especially if you're just getting started. It's very important to identify something that's realistic. And then it's very easy, once you've satisfied the first modeling problem, it's very easy to then build up on top of it. So it's important that you don't start from a very complex problem. It's a lot easier to just build up to the complex problem. It's also important to think about the time and effort that is going to go into the project and into the modeling. And this brings me to our second key lesson, which is how do you understand timelines and effort required for predictive analytics? This is a lot harder than it would be for something like a purely application software development project. Estimating timelines, it's a lot harder for machine learning. It's important that there's good communication with stakeholders, and it's important to be clear that this type of development is a very iterative process. There's a lot of iterations, there's a lot of experimentation, there's a lot of trial and error involved. And it should probably be approached more as a research project than building a product. In our experience, the product discussion, it's better to start that a little bit later in the development process when you have a more clear idea of what your model is actually capable of doing. You might think you've identified a realistic use case, but then you realize you need to maybe just take a couple of steps back and simplify the problem. So at that stage, you're in a position where you know what you can predict, you know what data you have, and so you can start talking about, okay, what would this look like if we were to carry on with this project and start thinking about it as a product? And that discussion is very helped by another key takeaway, which is the importance of embedding subject matter experts into the conversation. It's important from the start to agree on what success is going to look like for the effort. It's important that you decide how you're going to measure the impact. And measuring impact can be done in different ways and from different perspectives. From a data science point of view, you're obviously interested in how well your model is performing. And there's a number of well-established metrics to do this. It's just statistics. So that's relatively straightforward. Understanding and measuring the impact on the business itself can be extremely more complicated. And so it's important that you sit down with the people that will be using this model, with the people that understand how the business works, with the people that understand how the organization works, and understand where the value will be coming from and how you're going to measure it. Something else that's obviously extremely important is establishing a shared language, right? There's all of our projects within JPMorgan, it's always a two-way education process as well. For us as a data scientist, there's a lot of learning opportunities when we work with things like our investment bankers, some of our internal operations team. And for them as well, this is a bit of a learning journey. So they understand a little bit better what we can and cannot do, how our models are working, and how our products are structured. The last point that I wanted to make is understanding that failure is a result. And this is a direct consequence of approaching this as a research problem. Once you've implemented a solid post-mortem process, which is basically looking back on what went wrong, assuming you were not able to build a model, it's important to look back, understanding what happened so that you avoid those mistakes. And there's a lot of learning opportunities in there, because through the process of building the model, you've gained a better understanding of your data. You've gained a better understanding of your capabilities. You now understand probably better how your variables are correlating. Maybe now you understand also how to look at the problem in a different way. Another absolutely key element is being able to document this knowledge and these learnings, because again, this is a journey within a journey, and you cannot build on top of what you've done if you're not able to track the knowledge that you've gained from your efforts. So these are sort of the very important things to keep in mind if you're thinking about applying predictive analytics in your organization. And all of these elements come together in all the conversations that you're going to have, either with your technical data scientists or with your non-technical stakeholders. I think these are key points that it's better to address very early on in the process. If we go to the next slide. Thanks. I wanted to just touch on how you can start developing some of these capabilities. And this is in no way an exhaustive list, but these are some of the things that have worked for us. And so starting from the left, obviously there's the training in-house talent. So the idea here is to look at your workforce. If there's someone that's already maybe a little bit familiar with some with some descriptive analytics, maybe they're interested in data science or coding, even if they've been doing some a little bit simpler efforts like modeling things in Excel or some data visualization with BI tools like Tableau, Power BI, then those are excellent candidates for you to upskill. And they can start, with some simple use cases, leveraging some out-of-the-box tools that are available, and we will be sharing some resources in the next slide. But I think that training in-house talent is an obvious first step to start and explore the possibilities of applying predictive analytics. You also have the clear advantage that if you're training in-house people, then they're already subject matter experts, at least to a certain extent. So that's going to make all the conversations that you're going to have downstream a lot easier. The second key element to starting on this journey, to getting started on the journey, is leveraging the open source software that's available. There's a lot of resources. It's absolutely mind-blowing how much stuff is available for free, with amazing communities of people that come together to help out people that are getting started. Open source is by far the fastest way to access predictive analytics. Again, you rely on these large online communities that can provide you with examples that you can just customize a little bit, and you're actually doing predictive analytics, and that's it. And if you have problems, you can go on forums and board discussions, and you can ask all kind of questions. And obviously, leveraging all this open source software is removing a lot of the implementation complexity that would come out of starting this journey without leveraging the open source software that's available. The third point I wanted to make, and this is again coming from our experience on how to attract talent. So obviously we're looking at, data scientists, data analysts, and these kind of profiles. And these are things that we are observing ourselves. It's like, what do people really care about when they're picking their next job? People really care about the impact of their project. So I think for the kind of organizations that are probably listening to this now, it's very important that you emphasize the impact that these projects can have. People truly care about, doing things that do have an impact. Also, it's important that, providing opportunities for some sort of exposure. So public speaking, writing articles, publishing online, allowing this kind of activities is a very strong point when it comes to hiring and attracting talent. And there's always the element of, ensuring growth, personal development, and this can tie back into the first suggestion, which was training. This provides ideally you never stop learning once you've started working on something. So encouraging this kind of learning opportunities, making sure that there's a growth and a personal development, that's also extremely helpful when attracting this kind of talent. Lastly, if we move on to the next and last slide. So here's some of the, again, this is just a small selection, very small selection of resources that are available out there. So there's some, online training platforms, there's some open source and code examples. The third element has changed a little bit, and these are the, sort of machine learning, predictive analytics as a service. Probably some of the organizations are already using some of these service providers for their data storing or things of that sort. If you are, then it's very easy to, again, leverage the same providers to look at some of the things that they're offering as a service out of the box. So they might be offering some pre-trained models that you can simply plug your data in and see what comes out of them. They might be offering some platforms and infrastructures and pre-built architectures that can simplify your journey as well. So it can also be worth looking at some of these service providers. Again, this is obviously a very small selection just to give you a bit of an idea of what's out there and helping you out to sort of see some of the examples so you understand a little bit better what to look for. So I think this was again, the last slide. So Ali.
Yeah, thank you so much, Rio and Andrea, for taking us through predictive analytics. Super interesting there to hear some of the case studies and how valuable predictive analytics can be. We're getting some interesting questions, so just wanted to share one here. We're a small organization. How do you suggest we begin on the journey towards predictive analytics? So I think that's a question for you, Rio, in terms of where you mentioned at the beginning between the different stages between descriptive, diagnostic, and predictive, and how do you start that journey?
Yeah, sure. I think obviously with when it comes to just starting off with analytics, the easiest entry level would be descriptive analytics. And there are great online platforms. I think a couple were mentioned here already, like Tableau and Power BI, that you can use to input your data and then build visuals just to get a good understanding of what's going on in your organization. But I think the key thing would always be to make sure that you have data. So if you don't have data to begin with, then you can't really do anything with it. So all of these are data-driven methods. So I think the key is just to make sure that you're data acquisition is good, and there was a talk on that on Tuesday, I believe. So making sure that you're sourcing the right data in the right ways, and yeah, once you have the data on system, it's then possible to do things with it.
Great, thank you so much. And Andrea, you mentioned earlier around timelines and effort being a key aspect to consider. But for the audience, for a non-profit organisation who may not have a data science team in-house, are there any suggestions you have for off-the-shelf solutions or ways that kind of you can leverage predictive analytics without being restrained by that?
Yeah, absolutely. So again, I'll remind to the last slide on the resources, where the section on the right has got some resources that can be leveraged out of the box. Some of the open source libraries available are basically ready to be leveraged almost out of the box with very, very little effort. So even without a dedicated data scientist, if there's anyone that's got even just a little bit of coding experience, Python is probably the most used language, but that can be done in other languages as well. I think that's a great place to getting started, because again, the example, that's actually how I got started myself. That's how I started learning, is the examples they have online are extremely useful, because it's very easy to take those 10, 15 lines of code, and all you have to do is change the data that you're feeding to it. So instead of using their sample data, you use your own data. And then see what happens. It's exactly like that. It's a very, very straightforward journey. The resources are incredibly helpful. Google becomes your best friend within half a day, obviously. But I think that's a great way to really get started quickly. And I think once you've done this process of just seeing what happens, then immediately becomes clear, what to do next and where to go next. Again, keeping in mind that you should probably get started from a simpler use case, and the predictive analytics is assuming you're building on top of, your descriptive analytics and your data visualization. So everything that Rio was mentioning earlier, that's sort of a prerequisite to starting building this type of pipelines. But yeah, I think between the open source and the as a service platform, they also offer free trials, by the way. So that's a possibility. Even if you're not already engaged with these platforms, then you can go through their free trials, and there's this kind of things that can really help you to get a concrete feeling for what's going to happen.
And on that, are there any key areas where people should be looking at to make sure there's no kind of mistake in the data? So you mentioned there kind of obviously copying the code and leveraging open source, but what are the key things to look for to make sure kind of not creating any biases or anything within that data?
Yeah, that becomes obviously it's a sensitive issue. It's something that one should be extremely aware of. Again, I think if you're building on top of a strong descriptive analytics foundation, then you should already be aware of some of these elements in your data. I also think if you're choosing sort of a little bit easier use case, sometimes you can just avoid these problems altogether by simplifying your use case and maybe removing some of the assumptions you're making on your data. So it can really help to try and maybe break down the problem that you think you have, try to break it down into smaller problems that can be solved incrementally. That also helps a lot. As far as the technicalities on bias in data and bias in your prediction, those can actually be spotted again using some descriptive analytics, but you're doing the analytics on the output of your model, right? So it's what I was saying earlier about how your model is also producing data, and that data is going to go through the same journey that your input data has gone through. You'll be exploring your model predictions. You'll be using visualizations to understand what your model is predicting, if your model is a little bit unbalanced, if there's any bias. These are all things that can be spotted through the same processes that you've ideally already applied to the data you have.
Okay, great. Thank you for that, Andrea. And then we've got another one here. Ria, maybe you can take this one. Presumably, the failure rate for predictive models may be quite high when an organization starts sort of working towards predictive analytics. How can this so-called problem be communicated with senior management to avoid any concerns when it might be perceived potentially as a wasted resource? And obviously, that's key for the nonprofit sector.
Yeah, of course. So this is a big problem actually when it comes to just designing workflows for building statistical models. And I think Andrea also alluded to this when it comes to machine learning or statistical model building. It's not really the same as traditional software development. It's often iterative and it often results in failures. And we like to be optimistic as data science. We like to say we learn from our mistakes, and we often do. But sometimes it does also feel a bit like wasted time. But one of the ways, at least in Bloomberg in global data, the ways that we've tried to tackle this fairly recently is to introduce operating models for these kind of projects. And one of the strategies would be to time box certain things. So say you allocate a month to this, to making a proof of concept. And then if within that month you don't end up with something that's reasonably viable, you move on. So that's something that is, I think, a lot easier to communicate to senior management that might perhaps have less of a nuanced understanding of the difference between traditional software development and machine learning or statistical models. And in that way, you can sort of say, okay, we're going to spend this time trying, and then if we fail, we'll move on. Fail fast and stay agile. And I think those are things that senior management will understand. And if you communicate in those terms and you have an operating model in place, I think you're in a good position.
Great, thank you so much. And looking at kind of some examples here, Andrea, do you have an example where you can share where you found something that you weren't expecting when you applied predictive analytics?
Yeah, we actually, that does happen quite a lot, and there is a great result when that happens. That's kind of what you want. I'm gonna reuse one of the case studies, the one on our process optimization and the workforce analytics effort that we've done. And I'm not at liberty to share the details of what we actually found, but we were able to identify extremely different patterns between different teams within the organization that we expected to look similar, but they were not quite similar. And we were able to trace back to the simple fact that someone from senior management in one of the teams actually gave himself training to his team on an automation tool. And so that team was probably something like 30% more effective, simply because their senior manager was familiar with the tool and was able to train people. So that was a surprise to us, because we had no idea they were actually using the tool. And but again, the fact that we were able to first identify the discrepancy, then we were able to trace back this anomaly detection effort, right? We're able to trace it back to the root cause, and we're able to look at the details, and we were able to spot exactly what made that difference. That was actually a great result for us, and it was quite unexpected. A number of findings were also sort of surprising to us. You know, some of the teams actually are able to stay productive by using tools in a little bit more creative ways. Again, I don't want to necessarily go into the details, and they're probably not even relevant. But I would say, you know, again, on the point that the predictive analytics modeling can be useful not just for predictions, but to look back at what is happening. Finding things that you not expect, it's actually what you want to, right? So it happens quite often, and we're happy about it, because that's what we're trying to do. Because then you can ask the question as to the why is this happening, and usually the why question is what's generating the value for the business.
Great, thank you so much for that, Andrea. And another question here is, one of the key concerns we have is trying to identify the type of data that we could actually use for predictive analytics. So Ria, maybe you spoke about data-driven knowledge earlier. Maybe you could take that question.
Yeah, sure. I think outside of I think obviously within business analytics. So traditionally we talk about predictive analytics as part of business analytics, and in that framing, it's all about optimizing your business and making your business decisions better, or your organizational decisions better. So the assumption there is that you'll be using some kind of internal data. So I think it would just be making sure that you're leveraging your company internal data as well as you can, and that would be personal data about staff and things like that, in a way that you can then leverage that data to make better business decisions. But I think what people often think about when they think about building predictive models is predicting almost anything else. So I don't think there are really any limits in terms of what data you could use to build predictive models. But strictly within the framework of business analytics, it would be company internal data, is my assumption. But then if the question is more about how are we modeling that data, or how are we like ingesting and integrating that data, I think it would really depend on the size of the project. So you might be able to get away with doing an entire predictive model, essentially using Excel and Jupyter notebooks, and that might be all you need. But to do something on a larger scale with more data, you might need further resources, and you might need to lean on cloud services or platforms that allow you to do this using more resources.
Perfect, thank you so much. And then another question here on how you actually, how many scenarios is the right amount of scenarios to actually run? How do you know when to kind of stop when you found out the right amount of information? So maybe Andrea, you can take that one.
Yeah, I mean, the honest answer is we don't know, right? But the truth is that that's where talking to SMEs becomes absolutely fundamental, right? Because if you think about from a statistics or mathematics or data science point of view, you can build infinite potential scenarios, right? You can change any variable. Most of variables are not bounded, so you could have infinite scenarios. But the truth is that realistic scenarios that actually have value for the business, there's very few of those. And as a data scientist, I don't know what is realistic or not, and I don't know what has value for the bankers or the business in general, right? But there are people who do. So part of my job is making sure that I'm asking the right people, what do you think we should actually be concerned about? It's like, what would actually have an impact in your opinion? What is more realistic? What is, within the realm of possibilities at least? And that's where you sort of start to, bound a little bit the amount of scenarios you can look at. So that's again, it's very important to embed the SME's expertise. From a more statistical point of view, you can also, again, by looking at your variables and doing some data exploration, you might be in positions where some of your inputs actually have the same effect, more or less. So you can also cut some of these scenarios by saying, okay, we got, this variable is quantifying risk. This is also quantifying risk. They're heavily correlated. They more or less have the same impact on our predictive model. So we can test one of them and there's no need to test both of them, right? So it's, again, coming in from both ways, subject expertise, little bit of statistics to clean up some noise. Then you usually are able to find a realistic, sustainable amount of scenarios. If you want a number, obviously the thing is also you're automating these processes. You write the code once and then you can just leave it running overnight. So we are able to test hundreds of scenarios per hour if we wanted to. We actually don't. We don't need that number, right? We probably do 50 to 60 a week, and that's plenty to cover all of our, client engagement worries. Like, oh, what would happen if we were to do this instead of that? These are the kind of scenarios and how they come up. So we don't need a large scale, actually.
And Rio, would you add anything to that? Are there any additional tips or ideas for how you look at the process and when you know when to stop?
Yeah, again, I think I just echo what Andrea said about SME knowledge when it comes to deciding when to stop, I suppose. It would be a case of making sure that the right people are being asked the right questions.
Okay, perfect, thank you. And then this is quite a specific question, but in terms of the email case study that you were walking through earlier, are there any kind of plug-in solutions that someone in the audience might be able to use rather than having to kind of code that up themselves for email specifically, Andrea?
I guess it would depend from what you're specifically looking at and what you're interested in predicting, right? To be entirely honest, I'm not necessarily too familiar with all the available solutions out there. So yes, there is probably something that you can leverage out of the box, and I'm not aware of it. Again, it depends heavily from what exactly is your goal. What I'll say to help your Google search, whoever asked the question, if you're looking at processing email data, then this is what would be called unstructured data, because it's not a table basically, right? So it becomes a little bit trickier, but actually because it's trickier, there are more services that are already doing that. And so you would be looking into maybe some natural language processing, NLP for short, that becomes, and I think the next session on, artificial intelligence as a whole, gonna talk about natural language processing because there's a lot of value in there. But then that becomes a step that you perform before your predictive analytics. So you would use some NLP to extract information out of your emails, and then you would feed those informations into a predictive model. And you feed the information in a way that the model can actually process them. So on the NLP side, there's a number of services available out there. I don't want to give specific recommendations on one service rather than the other, but all main service providers, so if you look at Amazon, Microsoft, Google, and IBM, they're all providing out-of-the-box natural language capabilities. They're also providing a number of predictive analytics models that you can immediately use. But yeah, definitely attend if you're looking at emails, definitely attend the next session.
Okay, great. Thank you so much, Andrea. So in terms of to leave our audience with kind of at a high level takeaway on predictive analytics, what you think is kind of the key things. Ria, I'll start with you.
Yeah, sure. I think, I think making sure that your data is in order is probably the best thing you can do for any data-driven analysis. So as I said at the beginning, just predictive analytics really comes once you have a very good understanding of what's going on in your organization, and also why certain things are happening and what the patterns mean. Because really you can't realistically expect to use the data to predict what's going to happen in any meaningful sense if you're not sure what's causing what's going on underneath, and obviously what patterns there are as well. So yeah, I think making sure your data is in order, and then just building nice dashboards and getting a good understanding of your organization, and then you might be in a position to sort of ask more complex questions.
And Andrea?
Yeah, I think a very important message is that predictive analytics is never a team effort. It's always an organization effort. It's not going to work if you don't make sure that all the right parties are involved throughout the process. Establish clear line of communication from the start. Make sure that your SMEs and your stakeholders are involved. They clearly understand what is happening. They don't necessarily need to understand the technicalities of how you're training a machine learning model, but they do need to understand what you're trying to do, what data you're using, what data you're hoping to get out of this model. So establishing those kind of communication lines, it's absolutely fundamental. Not necessarily to the success of a project, because if you have established clear communication lines, then everyone understands that failure is a result, right? So it's not necessarily going to guarantee that the specific modeling you're working on is going to be successful, but if you think about the journey to predictive analytics, then yes, that's going to make it a successful journey. Clear communication lines, involve the stakeholders, involve the SMEs. I think it's extremely important, and far more important than the technical details or the actual, technical capabilities of your team. That's not as important as clear communication and the organization-wide effort toward predictive analytics.
Okay, great. Thank you so much. So that leaves me to say thank you so much, Ria and Andrea, for an engaging and informative discussion. I think we learned a lot and lots of resources there to take away, so please do check those out. Just like to say that we have one more session for the day, which is on artificial intelligence. As Andrea mentioned, if you're looking at emails, do please join that next session. Should be super engaging and interesting. And lastly, our closing session is at 3 p.m. this afternoon. Will be a closing panel hosted by Gideon Mann from Bloomberg. And with him, we will have some of our nonprofit partners from DataKind, the Felix Project, Zero Gravity, and Fair Education Alliance. We really would love you all there to join as we have our final thoughts on this week's Data for Good exchange event. So look forward to seeing you there, and thank you again both to Rio and Andrea.